sound check. 1 2 1 2 1 2. Okay, looks good. Chat test. Chat. We are good. Okay, let me start my connection here to my shit. Why are you here? Okay. What's going on? Connect. Okay. Looks good now. Seeing fine. Let me open Fusion. Okay, guys, sorry about that. Welcome, everyone. We are back to the Milo modification series, CAD series, let's call it that way. So, as if you are new here, we are gonna build a CNC Milo in the next couple months. So I have experience with CNC machines, designing CNC machines, making CNC machines, working with CNC machines. So I want to make my own twist on that. So we are doing some modifications to the version 1.5. I'm pretty sure it's gonna come out a new release soon, since usually when I start working on something, they decide to make an upgrade on it. But anyway, so we have we are working on the 1.5, which is the version available to everyone, and I have a kit from LDO, and we are working based on that. So yeah, we did one axis already. We did so right now we are working on a function model. It's what I call the simplified function model. Basically, it's with all the really necessary dimensions, but not with the fancy looks of a render. Just to keep it simple, test movement, test interface, test interferences, like between parts and whatsoever. It makes it easier to see if everything fits, if we can do some stuff or we can't, or if one part will eat a screw or whatsoever. So it's easier to see all of that. So that's what we've been working on past streams, and meanwhile we're gonna insert the parts that we want to modify or make or whatever. So the point is, again, I want to use the most I can from the LDO kit, but also insert my modifications. So I'm gonna mill all parts from aluminum. Maybe we'll make a kit from that, from the modifications I'm making, but we'll see how it goes, and depending on the interest of some people. So yeah, let's move to Fusion. So give me a second. Let's see. Okay, we have Fusion. So these are the parts I was working a couple days ago, And yeah, sorry, I was supposed to stream on Saturday and yesterday, but it got chaotic really fast. And I wasn't able to. Yeah, I was checking. Yeah, everything is streaming. Everything looks good. Okay. So, what am I looking? I'm looking for BMSP tools. So BMSP tools, and now Milo. Functional assembly. And we're gonna need to make some changes, which I'm gonna be talking in a minute. What is the model? Oh, it's here, functional assembly. Hey, another CG, welcome. Okay, so yes, we were working on the X model. Okay, since we're gonna do custom ball screws anyway, I'm gonna do some changes. I was thinking about all of these, so I want to minimize this. I mean the motor being the least like coming out the least as possible. So I designed this as being something, and okay, yeah. So these are, can check here, 104, and actually I already bought, so these are supposed to be closed loop steppers, and I already bought I found a nice deal on motors, and I ordered 3 sets of closed loop steppers, which were these ones. Give me a second. These, well, they are more expensive now. But yeah, I ordered it's the same. It's not actually these advertise, or these item. It's from this store, but this is a different. Yeah, okay. So yeah, because it comes from Poland, they don't have that available now. It was cheaper. It cost me $170, 3 sets, which was awesome. But it's the exact same motor, and it's smaller than the one it's supposed to be. Okay, so it's supposed to be 75, 95 total from back to front. So it's a little smaller. So let's edit our. So what? It's 1 centimeter smaller. What is the so fusion? So I'm gonna change that. Update that. Let's call it that way. So from here we have. Oh, I didn't. Shit. Okay. Oh, that sucks. Okay, so I forgot to do this last time. I need to do a capture history. And let's do split body. Select this body. This is the tool. So we can split. Now we have two bodies. Body 1. And let's hide that guy. So we need to drop from 104.5 to 95.5. So let's drop 9 millimeters here. And now let's align this like that. Now let's just select both and combine, and done. We have a single piece already, and we have 95.5. So I'm gonna save it, and I'm gonna also update the name. So rename. Let's put 95. It's fine. Other thing. Let me try to find it. Okay, first let me change the language on my AliExpress. No, I don't want to predefine it. Okay, so language English, and coin can be dollars. Yeah, I know you guys are not seeing, I'm just preparing. Wish list. Pretty sure everything I have here can be shown, but I have a bunch of stuff I need to close. Okay, so I found out the couplers I want to use, and yeah, these are the couplers. So they are 2020, so they are smaller. So I'm gonna need 8x8, and actually I haven't bought these, but I will. So I'm gonna change also the design of the couplers. So these are smaller. So let's do that as well. This is all in order to keep this thingy the closest as possible to the machine, and keep the machine footprint as small as possible. So I'm gonna rename it from 2020 to 2020. It's gonna be 8.8 on my motors, but fuck. Eight. So for the if I decide to go with the kit, I will have these parts So these are the parts that that will change according to the length from these. So I'm gonna design them in the way that I'm sorry, I'm just killing a bug that's here. So the only difference is these parts will be shorter or longer. So I'll be either I'll provide both of them or making into parts with a spacer, and if you need the longer ones, you put a spacer in. If you don't use the spacer, something like that. I'm not sure yet, because of the only thing that will change is these blocks. And let's be honest, for now I'm gonna try to keep it smaller, but if it fits on the enclosure that's already designed like this, I'm not even bothering, and I'm gonna keep the longer thingy. But for now I want to keep it as small as possible. So yeah. So I'm gonna change this to 20. And that's fine. Probably these -8, and same on this side, -8. These may change again, I don't know, but for now let's change it, and it's 20 millimeters. So finish, save, everything is the same. And I'm gonna also change, since we are using custom okay, since we are using custom ball screws anyway, we can reduce this distance in here. That's what I'm gonna do now. So from the beginning of the threads to the nut, we don't need the nut. We have about 4 millimeters that we can shave out. So this is the Y. I'm gonna change in both. Since we are using custom ball screws and we're gonna have them machined, it's better to just do it properly. So what I really need, so it's to reduce this guy. I'm gonna reduce it to 35. I'm gonna reduce the thread length to 14, and it's probably maybe 12. And even this guy, you don't need that much. We need 10 at maximum, so we're gonna do that as well. Okay, and now we're gonna increase everything because the ball screws are standard length. So these are supposed to be 550. So I'm going to increase this size. This is in here, 9 millimeters plus 9. Did it grow? I haven't seen it. Let's check. Yes, it did. And everything should be tighter now. Yeah, so we have the we have the threads finishing right on the end of the thread, which is fine. And we have everything closer, so we need to change these pieces. Let me check something else first. What do I want? Okay, I want to check the analysis. Let's see if I have... Yes, this is what I want to check. Okay, so yeah, everything is fine. We can even cut more the shaft of the motor. But yeah, it's gonna be... Yeah, maybe... I don't want to cut it too much. So... yeah, this should be fine. Yeah, this should be fine like this. So we can reduce from here to here. So about 10 mils. 9.5, 10 mils. Gonna drop this guy on these guys. So here. On this thingy, let's drop 9.5 mils. Like that. Hey, Rodolfo. Okay, let's see. Yeah, we are way closer now. We have a little of overlapping there, but that's not important. And we are much closer now from here. Let me open the original Milo design. Okay, so the Milo design, it's pretty much almost dead on. So we have 11 millimeters, and here we have, so we are 55. We have 55 more millimeters from the original design, but it's because the motor is bigger and everything else. But yeah, right now we are the smallest we can be in here, which is good. So this part now is only 37.5 millimeters, which is fine. Let me edit this just to see the... This is something to worry later. Okay, so yeah, we can change that. No need to go as deep as this, since we have something like, yeah, can use like 25 M425s in here. So we can drop these 10 millimeters. We can do it now before I forget. Okay, it's not this. What do I want? Yeah, it's this. we can do -10 here. What's the problem with the line? Edit feature. I have no idea. Why is it complaining? Edit feature. Oh, it's the second from here. It's a problem. Yeah, never mind. That's Fusion being Fusion. Okay, we are good. From here to here, 37.5. I'm gonna need these guys. Oh, sorry. Actually, these guys to be okay. 7 millimeters is fine because I'm gonna need to use a 12 millimeter mill to machine these parts, but that's for later. We can always refine them later. Okay, so we minimized the this is something that I was kind of worried, but we minimized and when the motors come in, I can actually take some better dimensions and check if they are actually this size or whatever, but for now we are good. Let's start off the section analysis and let's go to the x-axis. Okay, same story on the x-axis. I'm gonna change that already. And the idea, let me check something. Yeah, that's fine. Okay, I was just checking if that axis had the same thing. So this face from the PK block, it's yeah, it's at the same. Hey Joseph, nice, thank you very much. Okay, so same story. I'm gonna change the X ball screw design as well, since we are at it. So we're gonna change this guy to 35. We're gonna change the length of the length of the thread to, what was it, 12? And yeah, and this guy to 10. We'll deal with the length of the ball screw later. Not important right now. And speaking of that, let me check about the thread length. Oh yes, the thread length is fine. So the thread length is fine. It could be a little less, but it doesn't really matter. It's fine like that. So let's keep it. And let's update the design. Okay, fine. So we have these parts sorted. Yeah, we had this issue where we couldn't put the bearing block on the outside, and we had to increase the thickness of this guy, which is kind of a bummer, but there's no need to be this thick, but that's fine. Probably we're gonna counterbore these guys in order to be able to use the factory screws, but it's screws, it's gonna be cheap anyway, but stuff will add up. So okay, so we were last stream we finished in here. We were about to design design the double nut holder, and yeah, I guess we're gonna go with it. Let me check something on the other axis, because that's something I was edge 16. Yeah, but we can't play much with it. Yeah, okay, that's fine. I was checking about what I was checking is about the length of the screws we were using, because we're gonna need to put screws from both sides, and the piece is only 16 millimeters, but that's fine because we can use 6 screws. Well, we can use 4 screws on this one, and another 4. Well, actually on this one we can use all 6s, but it will be better if you use, it's gonna be the same, but it will be better if we use 4 on this one, and on this one we'll use again 4, but we can use longer screws on the, because we can't use the top screws on that one, because it will mess with these guys, with the cars. I call it cars, it's the carriage, the linear carriages, whatever. I call it cars. So we can use longer screws on this middle position, because we don't have screws coming from the other side, and then we can use the smaller ones. We can use like M4 20s on these holes, and 16s on those, because 16s will end up being off of the block, so we are fine, and we're gonna use washers, so the block has 16, so we're gonna be fine. And since this one is gonna be floating anyway, so we're gonna use the 4 ones, because it's gonna be preloaded. So yeah, we're gonna be fine. Okay, so now let's design the thingy for the X. So the thingy being the nut holder for the X. So the nut on this one can be bigger. The block can be thicker, not bigger, thicker, because we have way more space between the carriage on the X other than the Y. So we are good. We can use long screws and screws everywhere on all the holes like I like. So let's start with that. So I'm gonna make a new, and let's start. So a new design, new drawing, a new part. Let's start with a square of, let's call it 60 by 40. Let me open the other one, the one we use on Y. So as we saw, we're gonna need to refine some stuff in here later, but that's fine. That's functional, as we call it. So let me take some measurements. Okay, so we have 39. We're gonna go 70, and we have how much height? 35. So we're gonna go 45 here, and maybe 65. So, and let's go 70 for now, to start with. Let's make a hole for the thingy. The hole, it's gonna be centered in this axis, so in the y-axis on the machine, and here this position, it's unknown yet. We can figure it out in a minute. Yeah, we can figure it out right now. So for that, we're gonna need to mesh with this later. Can close that. Okay, so how we can measure it? So we have this thing pretty much in position. So what I'm gonna do, I'm gonna go inspect, and I'm gonna go show snap points so I can get the center point in here, and I'm gonna measure it against this point, which is in the top of the surface where we're gonna apply the nut holder. I'm gonna check here for a global where I can get all the components from that direct measurement, and I'm gonna get this one. This one, it's the one I want. So minus 18. We need 18 millimeters in here. So 18 in here. So okay, only 18. We're gonna need this thingy to be 22.5. So we don't need nearly as high as we have. Yeah, that should be fine. Even maybe 32. Let me put the holes. So if I remember correctly, and I don't, so I'm not even trying to. I need to check. What do I need to check? I need to check here. I need to check these holes. What's the pattern? So it's on a 32 circumference. That's what I wasn't remembering. So on a 32, then we have 6 holes of 4.8. That much I remember. Well, it's 4.8, but it's not 4.8. They're gonna be threaded M4. That's what I mean. So for M4 we have 3.3, and we're gonna reference these ones. Which one it is? D7. So D7, D7, and another one, D7. So I'm pressing C for circle, which is way faster than going there and press the damn. So this one, it's aligned with this one, this one with this one, this one with this one, this one with this one. Okay, let me move this away. Let me put this one here. So we need a reference line, horizontal, and then we need another line. I'm pressing L for line to this one. Let me move this guy here. Now I can call 45 in here. Okay, so this is what I wanted. So let's put 33, so we have a little more meat. We have a little more meat on that thread there. We should be fine everywhere else. Okay, so let's put this thingy like 30 millimeters thick, maybe more, probably 30. We can't go 30, we can go 29.9. Yeah, 29.9 looks good. If I have to use well, let's start with 29.9. Yeah, this should be plenty of beefy. And again on one side, well, maybe 29.9, it's too much. Let's go 25.9. Yeah, that makes me, yeah, that should be fine. And so we need to be on an even number. I mean, close to the even number, because we're gonna need the gap for the backlash, the anti-backlash system. So yeah, if I need to use a 30 millimeters piece to machine this, it's gonna be enough to have. So I'm thinking about the machining part of the piece, which is better if I have a little close. So if I use a 30 millimeters piece, I have 3 millimeters on the down, on 4 millimeters on the lower side to hold the part while machining. Yeah, that's fine. I like that. So we need on one side again these recess here for the so it's 25.1. So we're gonna call it, okay, we're gonna call this the X double. Well, there's no point in call it double, but because it's gonna work for both double nut or single nut. So, but yeah, since we have all caps on the other, let's keep it consistent. Double nut mount. Yes, this is the ball nut for X. I just want to keep the naming consistent, since on the other one I called it Y double nut mount. On this one it's going to be X double nut mount. We can actually delete the single nut mount because it's the same. So go away. There's no point being there. And we're gonna need a recess for the spring washers or disc washers or whatever. And if I remember correctly, we should be 3 millimeter deep, right? Oh no, actually it's 278. 2.78 minus, okay. So this is for the washers. So if I remember, so this should be the top part. So now we're gonna need to hold this thingy down. We can We don't need this thing to be, hey Kegel, how are you? We don't need this thing to be so, even so wide. Okay, so let's do some arrangements on the beginning. Let's call this thing 60 instead of 70. Yeah, that's way more likely. And let's put some holes in here. So we're gonna use 5mm screws to hold this thing. 2 should be fine. Yeah, let's make only 2, just to keep, because we're gonna need to modify the. Okay, maybe I need it. We'll see in a minute. We're gonna need to modify the original plate, and yeah, let's not make people drilling 4 holes when we can use only 2. So, oh, hardware store, shopping. So 9mm, I'm gonna reference for the same as that one. Let's align these guys together, and let's put them at, so yeah, 6mm sounds about right. Okay, let me see if I bore this thing down to, yeah, should be fine. Yeah, we are more than fine. Okay, let's bore it to 20. Fuck. Minus 20. Come on, Fusion. Yeah, because we need to put cut. Give me a minute, please. Go. Sorry about that. Oh, even the music stopped. Okay. Sorry about that. Just my aunt asking for some stuff. Okay, so I was doing the holes on this thingy. Okay, let's do 5.2mm holes. I'm gonna project this guy 5.2, and I'm gonna reference to this guy in case we need some changes. And oops, forgot to select the other one. So it's going to be something like that, and if we do a cross section of this thingy, inspect. I'm a little slow today. If we do a little cross section, it's going to be just fine. More than enough clearance for everything. And we can do then something like this, a big chamfer in here, something like, I don't know, 20 millimeters. No, okay, not that much. 15? That's too much as well. 10 maybe. 12. 12. Yeah, to make it a little cooler looking. Something like that. Okay, let me open the plate. So it's the saddle plate. So I need some referencing in here. Because these guys suck. I don't understand why don't they put the stuff in center and make everyone's life difficult. So let me save this. Let me save our... Okay, I'm gonna close our Y mount because we don't need it anymore. Let's put in the X mount, X nut mount. Should be here. Let me save it so it updates. Okay, so let's put it in here. Okay, so doesn't really matter, we can assemble it whatever. But let's make it like that. So for now, let me align it. So I'm gonna align the center hole, the center bore with the okay, actually that's good. So we can double check. See, we are at the same level, which is good. Oh, so we actually are on the other side. Okay. Okay, there's something. Yeah, I think we won't have a problem. I'm just checking if we need to screw this thing from behind or whatever, but I don't think so. Yeah, I think we can screw it from the top just fine. Okay, let's move it more into position. And one thing I want to check if we are centered on the bit. Don't think we are. Okay, we are barely off center. So on this side we have 32.015. Don't ask me why. It's probably related. I don't even want to check it, to be honest. So 32.025, and here we are. Oh, actually, it's almost a millimeter. Shit, it's actually. Okay. That's. I don't understand why they haven't done stuff centered. It's nonsense. But we need to keep, since we are keeping the original plate, we need to respect it. It's nonsense. Jesus, these things. Yeah, so 32 or 15. It's not even a close number. But anyway, doesn't matter. It is what it is. So it's pretty sure it's related to the holes on the for the cars. So the cars probably are weirdly offset as well. Yeah, same shit. So 16, 985 and 16 doesn't matter. I don't even want to go there. It's 1 millimeter. It's not even half millimeter offset, because since we have almost a 1 millimeter difference, it means that's like half of that off center. So anyway, let's move on. Okay, so let me orient my plate in the same orientation as this one. So we have the M5 screws from the bottom and on the two ones on the left. So it's like this. And what we're gonna do, we're gonna do a sketch Yeah, I'll need to seriously think how we gonna assemble this. But yeah, for now, let's do a 4.2 circle and another one in here. I'm gonna keep these centered. Yeah, let's start with it on center. Before I'll start machining, I need to, actually we can take a look into the assembly manual just to make sure if we can. I want to keep the assembly order close enough to the original one. So it helps if we can assemble everything in the same order. So we have 60, 24, I believe. I believe our holes are 48 millimeters apart. Let me call this guy the same as this guy. This guy the same as this guy. And this guy the same as this guy. Come on. What's wrong with you? Why isn't it fetching this dimension? Let's go the other way. That's weird. Oh, okay, because, yeah, okay. Never mind. You guys haven't seen everything. Okay, I need to capture design history first. Now, let me do the sketch. Otherwise, it won't be parametric. Yeah, what the fuck? So you're gonna be the same as this one. I'm not gonna trust that this thing is centered on the origin, so, and it's not. I only needed one. Now I need to let it be. Doesn't really matter. I believe we are on 48, so let's put 24. And same in here. Because our piece is 60, if I remember correctly. And I offsetted the holes 6 millimeters from the sides, so it makes it 48 millimeters. And we do holes, and we can do some chamfers. So 0.5. So this is something we're gonna need to do, but it's just 2 holes. Just need to make sure we measure it quite right. I can do, probably I will do actually, the holes on the thingy bigger, so it can allow more error on in marking this. And oh yeah, they can't be centered. Oh, I remember. We're gonna need to, I'm gonna need to delete that. What I'm gonna do is I'm gonna put them like that, and then we see. I can project this line here, and I can check on our drawing how far they are from here. And I saved it, so let's check if everything goes right. They should be, yeah, they are there. Okay, I'm gonna move this. Actually, I'm gonna check that. So we're gonna measure from this point to our center point here, and I'm gonna press the global. Okay, so we need to be 39 millimeters. I'm gonna put the 38.985 because of the genius that made this design, but should be fine with 39. So 38.985 and save, and we should be dead on. Okay, now we can align this guy with this guy, join. Shit. Okay, let me. So we are working on the X saddle, so the mount should be on the next saddle, on the X saddle. And it doesn't let me, so I'm gonna delete it. I'm gonna select the X saddle, I'm gonna import it again, I'm gonna orient it again, I'm not used to work with I'm trying to make this beautiful for you guys, like everything on the right components and whatsoever. Usually I just throw everything up and align stuff and join stuff without caring. So that's why sometimes I forgot to put everything where it should. J or join. And now this thingy should be aligned with that, and it is. So the x-axis in here, we kinda messed up because these thingies are not from the x-axis. These thingies, well, they are now. I'm not messing with it now. Okay, so what I'm gonna do, I'm gonna add 2 more washers of the disc springs. So for the anti-backlash thingy. There we are. So you're gonna put this one in here. J. Ooh. Then we're gonna add another one. And we're gonna move it like that. Okay. We're gonna join that line with that line, J. Boom. And then we're gonna join this one with this one, J. And we're gonna move it 0.1 millimeter on this direction. Whoa, 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 whoa. Okay, so it doesn't let me. Okay, I'm gonna need to delete the ball screw then, the ball nut. Because the ball nut, it's on the right, on the wrong component. I put it on the x-axis, but actually it's on the saddle. So I need to redo the ball nut. So 90. Let's make it slide. J with this one. Motion slider like that. And then we're gonna join here a rigid one, not a slider, and we need to put 0.1. Fuck, not here. Oh yes, it was 0.1. Why? Cannot resolve component positions because error conflicts. Shouldn't be. So we have the ball nut. The ball screw is inside the x-axis. Is it something rigid in here? Probably. Okay, let me delete that joint. Okay. So I think this was the problem. Yeah, okay. It was because I had the table pinned. Will result in, no, it will still result in conflict somehow. 0.5, 0.1. What am I missing? Let me see. Okay, so I'm gonna unpin the table. I can move everything in here. I can move it in here. Motor mount, FK10. Double nut is fine. Okay, why? Okay, let me check the joints in here. We have a slider. Oh, no, so this is a slide. It's only a slider here. Which slider? It's this one. Okay, I don't need this slider. I think that's the problem. Because we have already a slider on the guide. So, yeah, okay, that was a problem. We have two sliders on the same, doing the same sliding. We don't need that. Okay, okay, that was a problem. Okay, fine. We have a slider on the rail and a slider on the ball screw. And Fusion wasn't liking that idea, with some reason. Okay, so we need a second nut. Okay, let me. Yeah, we are on the right stuff. Okay, we need a second nut. So the second nut will be on this orientation, and let's just join this thingy with this thingy. And here we can use screws everywhere, doesn't matter. We are actually on a grate. Yeah, we have a little bit. No, we don't. That's a gap that's supposed to be there. And we have access to all the screws, kinda. We don't need these, because this is where the lead screw nuts originally get attached. And we have our, oh, where can we check it? Probably there. Yes, there. We have our anti-backlash nut system attached, as you guys can see. So these, let me put a little more. Shit, like 45, 55. Yeah, 55 looks good. So we have our, so this is our fixed nut, so that's our guide. This is just the floating nut with a preload that those washers will make. And we should be good. And if we use only one nut, we just need to use this girl on this side, or this girl on this side, doesn't really matter, and screw it together with the block. And we don't need the washers, the second nut whatsoever. So this single piece will work for both. And we have, actually, we can make it a little. The ball screws will be custom. Yes, the ball screws need to be custom, but the ball screw sellers, they will machine them according to your design with no extra cost. The ones that have already the so if you buy a ball screw, which they will machine the ends for the BK blocks, the BKBF blocks. So it won't be extra money. So it doesn't really matter as long as you provide the design, they will machine it with no extra cost. Instead of doing the standard machining for the BKBF blocks, they'll do whatever you ask. So the only one thing I'm thinking, maybe I'm exaggerating, let me check. So we have 13 millimeters with 8 millimeters, that's 20. Yeah, it's fine. It's fine. The only way I could make this thinner, it would be 21.9, so I could use 25 millimeters aluminum instead of 30, and then 16. Yeah, it should be fine with 16. So yeah, let's make these things thinner. Let's make these things thinner. There's no point on such a huge block. So let's make it 21.9. We can close this. This, nope. And everything else should be fine. Yes, like that. Yeah, it's thinner. There's no point. We have 10 millimeters. We can use M4 either 16 or 18s, and probably even 20s, probably, because we're gonna use, that's no 20s no, because we're gonna use a washer here. I think the washer is 1 millimeter. So that's 11, 19. Yeah, probably 20s. It's pushing, but it's possible. But 16s, it's fine. And yeah, it's easier to machine. It's cheaper. It's not easier, but it's cheaper because it's going to use less aluminum. So it's fine. Okay, so we can work on the end block. So let me activate the table. And actually this will be on the x-axis. So shamefully, we're gonna need to use a bigger ball screw in here, even with more. Yeah, so we're gonna need to use a 600 millimeter ball screw on the X. But it is what it is. Okay, so we're gonna need pretty much, I'm gonna copy the X motor mount. Actually, I need to rename it because mount, it's misspelled. So I'm gonna copy that. No, actually, let's refine it first, and then I'll copy, because pretty much it's gonna be the same shape. So I think I have 8 millimeters on top, so I'm gonna put an 8 millimeter chamfer on here. I'm gonna round it here like 8 millimeter. Same here, same here, same here, same here. Boom. Something like that. Oops, I forgot one. Forgot this one. Probably here it's gonna be even more. I'm not sure. Let me save like this and let me see. Yeah, maybe not. Maybe not. Maybe it's something like that. Yeah, should be fine. We might need to adjust this. Should be fine. But it should be very close to this shape. Well, we don't need solower. Yeah, we don't need that. Let me check on Milo if there's a purpose for being so low. Oh, it's because of the... Okay, I see. So it's because of the end stop and the drag chain. So yeah, we can leave it for now like that. We can always make a printed piece because it's quite a big. I don't know. Because I'm gonna need to buy a big block of aluminum to make these, even if but I can't machine them together because they're gonna be different thickness. So yeah, it's gonna make it a little cheaper if I make it like this smaller, because it's gonna be all this length. So yeah, I think I prefer it's gonna be an extra setup because I'm gonna need to put some holes on this face. Or not. Or we can just use the same ones from the end stop. Yeah, I think we're gonna do that. And I'm using a smaller end stop, but I'm gonna do the same pattern in case if people want to use the regular thingy. So let me check where this thingy it's gonna hit. Oh shit, I can't. Well, I can on mine. Mine it's the same dimension, I believe, right? So we have 80. And we have 80. Yeah, that's fine. So if I go here, oh yeah, okay, so we're gonna eat, yeah, that's fine. We have plenty of meat in here, even if we do a plate under the end stop, it's gonna be fine. It's gonna have plenty of space to, even if it's a 5mm. How much is from here to here? That's not really what I'm looking for. I'm pretty sure it's less than that. Inspect. Let's put this. Actually, let's put this point there with this. Gosh. So this point with this point. So we have, oh, actually, yeah, that's 17mm. That's a lot. Okay, we are good. We are good then. We are good. Okay, so the only thing I need to add, and I'm gonna do that now, it's 2 screws here, 2 holes here. So seam, I believe they are M2, M3, so 2.5s. Okay. If I remember correctly, I made everything same as this one, except mine it's 2mm less. No, it's different. So where can I get a reference? Okay, I'm gonna get a reference from this hole. Let me disappear with this guy. Yeah, I'm gonna disappear the... Fuck you. Okay, I'm gonna disappear the switch. I'm gonna disappear the screw. Oh, it's an M2.5? Jesus. Hello, Jose. Test 1, 2, 3 completed. Okay, so these are 2.5mm. Fine. I'm good. I'm good. How are you? Okay, so I'm gonna disappear with this one as well. Let me check how long are these, or what's the distance between them. 9.5mm. Well, if it's 2.5mm screws, that changes. Vacation, Christmas, yeah. Yeah, I'm really yeah, but I'm gonna do the same. Okay, doesn't matter, we'll figure it out later. Okay, so it fits two M2.5, so these need to be 205s. Not 205, sorry, 205s. Because the thread of M2.5 is 0.45 millimeter pitch. So we're gonna need them at the same from this distance. This is gonna be tough. Oh, it's gonna be a tough one to make this part, but it's doable. So small. Okay, I need to check how far from this surface they are. Of course, they have a very nice and even dimension of 7.21, which is super duper accurate. Where is the home run switch? Probably they took it from the... Nope. Not even that. Just because. So I'm gonna put 7.5 or 7. 7, why not 7? 7.5. Worst case scenario, people will need to bend the little spring sheet from the switch. Okay, so I'm gonna project this this guy here, because it's where I'm gonna get my reference of the height. So I'm gonna measure from this so the center of that hole to the center of this one, and it's going to be 17.6. I'm going to respect that. Whatever. Okay, here. I'm going to respect that. I'm going to need to create a middle point though. And D for dimension from here, 17.6. Yeah, it's very close to this fillet. But yeah, never mind. It is what it is. Needs to be done. Okay, so now this way I have everything there. I'm gonna shave this thing at least. What kind of sketch do I have here? At least 15 millimeters. So here minus 15. It's gonna be plenty. Fuck. So looks like I have this drawing. Yeah, it's reference from the bottom. So I need to put -15 as well. And now I'm going to delete it, and I'm going to reference from the top so this doesn't happen again. And we yeah, we should be fine. We still need to make the motor mount, but we have enough room in here. So I'm gonna do some counter bores on these holes. 9.5. 9 is enough, but we can do 9.5. Speaking of that, let me increase this. Let me increase these as well. So, okay, let's make, okay, this one, it's the slave. So let me put this guy inside. 9.5 and increase, actually, let's make it 10. Because these need to allow some user error from the drilling operations. Let's make it even 6 millimeters. Doesn't hurt. So if someone, when people do the drilling on the mod on the plate, if they mess with the screws a little bit, it needs to be fairly accurate. But if they move a little bit, this will allow some wiggle. Okay, so let me make this the master. I like to put out the dimension out for the master. It's easy to, so D55, huh. D55, where's the D55? D55, 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 D55. Okay, so let's counterbore it a lot. Actually, I'm gonna change to 9, just to, so these chamfers won't be so close together. It's fine, but okay, so let's go. Nope. Let's go like -15 millimeters. The part is 27, so that's 12. Yeah, if we use like M525, it's fine. It's gonna be 12 millimeters, even if it's 20s, that's fine. So I'm gonna make some chamfers here. I'm gonna make a big one, like 5 millimeters. Okay, 5, maybe it's too much. Maybe 4. Just to, okay, just to make it a little more like the part will end up. And these will be something like 1s. One millimeters or 0.5s, maybe. Yeah, 1s. And this one will be one as okay. Yeah, that's what I was worried about. But it will complain now, but it won't complain. Okay, let's make it 0.8. Shouldn't complain with 0.8. Yeah. In cam it won't complain. It won't complain. I'm just making this to make it a little, just to show how it will actually end up. Everything can be 0.8. It's fine. It's more like the part will finish. I'm gonna remove these guys now, because I'm pretty sure even this one I have something referenced to those holes, and actually probably not this one. And the joints will complain that the face no longer exists or whatsoever. So let's see. Yeah, that's fine. So this is pretty much the how it's gonna. Oh, I forgot to do the actual drills on the side. Let's do that. This can be something like 8 millimeters, and that's too much already. So for the screw, the end stop, probably we're gonna make some kind of plate and extend it to the drag chain, or maybe I can make a couple of holes here and make a bracket, a 3D printed one for the drag chain. We'll see. I'm not sure about that yet, but we'll figure out. So this should be the final design, or close to the final design. We're gonna have some chamfers on this side, not as much pronunciation, but at least some. But I'm not gonna worry with that. I usually don't chamfer stuff. Actually, I'm gonna move this, so when I'm do the programming, I can just go back on the timeline and have everything unchamfered. It's better for do the programming, not having the chamfers. So, but for now, I'm gonna leave them. That's fine. Okay, we have the X mount done. We can update it. Oh, no, we don't. Fuck. So we still need something, right? We need to hold the motor here. So that's what we're gonna do now. So let me import the coupler, the small coupler. Okay, I fucked up. Move. Well, actually it's under, let me, yeah, disable this guy. I'm gonna line this line, or join this line with this one. J for join. Boom. Now let's import a motor here. Let's reorient the stuff like this and like this. And now let's join this guy with this guy. Boom. The fuck? What's going on here? What's this? What's the joint? Sometimes, yeah, Yeah, okay, I need to go back. Sometimes Fusion just do this shit. Pull back X3 here. I just need to understand what the hell is wrong. What's this joint? Edit joint. Missing reference. 2 missing references. What's this component? Okay, so this is the column related? No. Okay, so I'm trying to, usually when we select stuff, it will highlight on the side here on the browser, or file browser, or park browser, whatever you guys will call it. And you see, this rigid is something related with the X saddle, it says there, and it highlights it here, but if I select some joint in here, it will highlight it here and here, but it's not doing. For now, I'm just gonna delete it. I'm gonna find out eventually what's going on. Oh, probably it's okay. Okay, so looks like, no, this is the slider. So this is the joint. I'm gonna delete it and see. Everything is moving together. I can't separate the base or anything, so yeah, fuck it. Let's... Sometimes Fusion does this, and I really don't understand what's going on with it, but it is what it is. Okay, so I was joining this guy. Let me make sure the motor came into the... Yes, it came into the X-axis component. So I'm gonna join it here. Come on. It's not... It's rigid. Yeah, that's fine. Okay, fine. So we now just need to create the piece from here to here. Should be about 37 millimeters. So ideally we would use the same pieces that we used before, but we can't because we have no space for that, so we're gonna create new ones. So let's open the X motor mount. First, let's copy, because we don't need any of that shit for the other side. So let's copy the where is Milo? Functional copy, and we're gonna call it rename instead of motor X motor. Let's call it X. Actually this should be X big FK but we called it motor, so let it be. Yeah, let the point be. And now we can start doing some stuff in here. So I'm gonna open the, I want to keep the same basics, let's call it that way. So what I'm gonna do, I'm gonna open the, where's the other one? Yeah, this one. So I want to keep the same idea. So let's do the same idea. So these have like 10 millimeters, I believe. Yes, it does. So let's do the same. Okay, first I need to do I need to know where the motor screws will end up, so let me do some sketches. So I'm gonna do P for project. I'm gonna project that line in here. I'm gonna press X for instruction. I need a center rectangle so I know where the screw is gonna be. So NEMA 1023s have a 47 millimeter square for the hole position. So this is where the motor's hole's gonna be. So we should be fine. The motors have what? 5 millimeter? Yes, M5 screws. So sorry, we need to go here. So let me just make a 5 millimeter circle here for reference. So this is just so I can position the holes for the screws that we need to use to hold the pieces. So C for circle, we're gonna use M4, which is more than enough. And we're gonna go from here to here 5 because we want a 10 millimeter piece. And what else? Let's make a reference from here to here. I really don't like stuff floating around, so we end up with weird measurements. Here to here can be like 14 maybe? Maybe 14 is pushing. Or maybe not. Let me see. I was 7.5. So 7. Oh, okay, we are fine. 14 it's fine. Okay, so we're gonna do the same on the other side. 4.2. 4.2. This is gonna be horizontal with that one with that one, this one with this one, and they both gonna be from here to here, this same distance. We are fine. Finish sketch. Let's do some holes. -12 should be fine. Good enough for the so now we're going to create a new component. New component. Fine. Which is going to be, I'm not sure if I did that on the, no, I just created new body, so I'm going to do the same. I'm not going to even bother creating a component. Let's create a drawing. let's create a rectangle, sorry. D for dimension 10, which is the same thickness of the other ones. Let me highlight. Okay. So I'm gonna make it. First, I'm gonna center it with these guys, like that. Then I'm gonna say from here to here we're gonna have at least 6. 6 is too much. That's fine. 6 is fine. And then we're gonna get at least maybe 28. No, 28 it's too. No, needs more. 32. I was trying to, yeah, 32 looks good. Looks good. Yeah, let's start with that. And we need 4.2 millimeters here. 4.2. Yeah, that should be fine for now. Let's start extruding stuff. Okay, we need this little piece as well. Not you. Just a little piece. Yeah, that one. So we need 37.5. What? 12, 35.5? Is it? I believe we have 12 millimeters here, so 25.5. Yeah, that's the same. Oops, forgot something. We need this piece as well. Yeah, I don't like it. I don't like it. Okay, so let's make it 25. No, let's do other thing instead. Let's do the same as we have up there. Yeah, let's make it 5, but let's make this one 5 as well. Yeah, okay. Now we're getting somewhere. Okay, so now we're gonna do another sketch. Oh, wait. I forgot something. Here, we don't want join. We want to create a new body, because these are two separate pieces. That's why I was doing the component thing, but okay, so now we're going to create another sketch on top of this one, of this piece. We're going to project this point and this point, so we can create 4.2s and 4.2s, and we're going to create an outside one of 10 and 10 as well in here. Now what we're gonna do? Now we're gonna do something like this and go here, and something like this, and same story. This for now it's just stuff. We're gonna do something that looks good. Okay, this one actually looks good. So let's make this one parallel with that one. And so probably we're gonna do an angle on this one of 135, which is 45, sorry. And let's do parallel with this one. Parallel, sorry, I was blocked. And now let's see how it looks. Okay, selected this one too much. I'm gonna select everything except the holes, of course. Oh, let me, yeah, can be like that. And extrude 12 millimeters. Ah, there's something missing, right? This thingy is missing. Ah. This thing is missing. Yeah, I like that. I like that very much. Okay, so what we did here, we did trees and 12 sevens in there. Okay, so let's do some fillets, make it a little more beautiful. Hellish. Tree. Boom. Like that. I'm gonna elongate. No, actually I won't. Looks good. Now let's add some sevens. Looks good. I really don't like... Okay, that's fine. I see, I understand what it's doing. It's fine. Okay. Yeah, I like that. I like that mount. Yeah, I like that mount. Okay, so the only thing missing is the contour bars for these little guys. I think 7.5 is enough. I need to check. 7.5. Is anyone? Fine. Let's do how much we have on the other ones. Let's do the same. Let's keep consistency. We have, fuck you, from here to here. Oh, okay, I wasn't pressing shift. 22. Mine E for extrude minus 22. Boom. And now we're gonna copy Control C, Control V. Fuck. No, we can't copy. We need to mirror it. So what I'm gonna do is mirroring. I'm gonna mirror it in a right place. I'm gonna construct a plane, a mid plane between this face and this face. Okay. Now I'm gonna create a mirror from this body and the mirror plane this guy, and there we go. We have a mirror on the other side. I'm gonna disable the plane, close this, save. It's gonna be fun to machine these parts. Looks good, right? Let's see if everything matches, if we fucked up somewhere. Oh. Okay. We fucked up somewhere. Well, I fucked up somewhere. 25. Okay, it was, oh. Yeah. I don't know what it should be 25.5. Okay, I mispressed one key. That's the 12, and it should be, yeah, exactly. Okay. Way better. I was looking too high, but anyway. So let's go. And there we go. We can see the motor, we can see we have access to the, actually it would be fine. We can always make a printed part to cover later, to cover these. Doesn't really matter, so ships won't come to here. That's fine. Yeah, and we have that part done. So let's move to the other side. So let's open this guy. So first thing we need is we don't need nearly as thick of a piece. So I'm gonna start with a 15mm one. And of course, being 15mm, we can't do a 15mm bore. So let's do a 8mm bore. We don't need these holes. Go. You don't need, well, the drawing can be there. Doesn't really matter. So let me open the other part. So it's the YF10 block. We can mimic pretty much everything here. So this one, it's even thinner. But I want to have some meat there. I'm gonna make it, okay, so maybe instead of 15, I'm gonna make it 12, or 12, 13. 13 is stretching, but 12 it's fine. So I can use 15mm plate, and it's gonna be plenty for what we need. We're gonna do less here. We're gonna do 6. That's fine. Now, okay, I'm gonna close. No, this one, it's the, no, we don't need these anymore. We don't need these anymore for now, at least. We need these. We need, this is the one, no, this is the one I was looking. Okay, so here, this thing is smaller, so it's 37, 7. Okay, so this fillet is 7, and this square, it's 37 instead of 45, so 37. Let me reference this by this one. What more? This hole is smaller as well. 14. And we have a 6mm step. So this circle it's way smaller. So it's 28. And the holes, where are the holes? It's freezing in here. So the holes are 35. Holes are 35. And they are M3s. So this is why I like to reference everything by one. If they are the same, .5 because these are M3, fine, and here let's put 6. And this should be what we need, or very close to what we need. Let's check. So we have it here. Let me disable this. We are working on the x-axis. Oh, I haven't checked. Yeah, now it's fine. A little bit of overlapping here, but that's fine. And now let's put in the piece we just designed, the XFF10 mount. So we're gonna rotate it like that. We're gonna use that guy there. J, rigid mount, fine. Everything looks good. This thing should be centered. Now let's import another FF10. Where is our FF10? How is it? Oh, it's on the right orientation. Looks good. Let's just put it in here. That's J. Okay, we can actually get this thing a little deeper. Okay, 7. So let's do 7 here instead. So it's flush. Okay. So now what we need to do, let's measure how much we have from here. Fuck. Come on, what am I doing? Okay, so we have 31 millimeters. So that's how much we need to grow our ball screw, which sucks. So we need to, oh, it's open here. So let's do 31 more, plus 31. Doesn't need to be exact. because again, this bearing here, it's a floating bearing, so even if we don't, it's not aligned in here, and I can show you it's not if I do a section view. Yeah, that one. Edit. I'm gonna flip it. I'm gonna move it here. So basically, hey, questionable choices. I shipped your order today. I haven't sent you the tracking, but I will. Okay, so as you can see, the bearing will float. It will align some error, like 2.5 millimeters for each side. So as long as the bearing is sliding inside of this bore, it's fine. And now let's see how long do we need to grow this thingy. So we need to grow it 28 millimeters to do the 600. I will probably they will cut it to length if you don't need this thing too big, but we can always cut it in home. But maybe it's even easier for them to just cut it to length instead of machining a big piece of this size. So I'm pretty sure they can be done to a specific length. I'm gonna call with depends on the seller, I'm sure. Depends on the seller you guys are using, but pretty sure they will prefer to cut out. We don't need that. They will cut out the thingy instead of needing to machine like a bunch more of unnecessary. So plus 28. It's gonna be a big ass piece and completely unnecessary. We'll see. I'll let you know when I order. I'm probably gonna order from CNA, which is the seller that they recommend on the Voron for the linear rails. I'm not sure yet. I also have a long relationship with the guy from BST, Fred from BST Linear or BST Automation, something like that, on AliExpress. I'm gonna give them both a call and see which ones are more willing to do the custom stuff and prices. To be honest, I have more faith on Fred because I know him from way long ago, like since 10 years or more, probably more, when I made my first CNC machine. And yeah, he's a nice guy, and they have quality stuff at good prices, so I may ring them and see. Actually, I want to ring them today. No. It's gonna be from AliExpress, so they are in China. But if I may talk to them, I don't know. I may be carrying kits for this thingy, since I'm pretty sure they won't modify the nuts, and if people want, I need to modify the nuts myself. But we'll see how it ends up. Okay, so we only have one. Yeah, this is a big ass long. There's absolutely no need for this. Pretty sure they will prefer to cut. We just need a little bit. If someone wants to put the manual handle in here, because otherwise this can be cut in here. Yeah, sadly. I can't make it, well, I can, but I won't make it smaller. Okay, looking good. We have just one axis to finish. So let's work with that now. I would really like to send some message today after stream. So we have 2 hours to get that axis done. Yeah, I may do that. We'll see. Because if they don't modify, if they modify the, well, it can be an option. I can sell the full kit if it gets to the point of that, or I can sell, like, I can have a full kit and I can have a ball screw kit, just the ball screws and the parts kit and whatsoever. I like to be modular on that stuff, and it's going to be exactly the same price. Like the full kit, it's going to be the price of the parts kit plus the ball screw, because it's going to be the same work for me, as long as you get everything. So I'm gonna have the same work preparing. The only thing needed is just join the pieces together. So if that happens, if the kit happens, I'm gonna be modular. It's not like, no, I'm gonna only sell the full kit. No. It's not gonna be like that. If you guys want to source your ball screws, you source your ball screws. If you want double nuts, you get double nuts. If you want single nuts, you get single nuts. Doesn't matter to me. And if you want the parts, the machine parts, you get the machine parts. Fine by me. Doesn't mean I'm not here to win. I'm not here to lose money, but I'm not here to win a lot of money either, so doesn't really matter. Okay, so let's go to the last axis. Let me see. So we have 416. And we have 460. So we have a little more than 1 meter. Well, actually more with the thingy, but I'm not worried about that. Okay, we'll check. I need to check the enclosure, but that's not for now. I really like to, I want to do the full thingy. So, okay, let's work with x-axis now. Z-axis, sorry. Okay, I can close these, I can close these. So first thing is I need to check the okay, so these we won't have any problems with length for the motor, because yeah, we have plenty of space, which is good. I may need to change the ratio. Well, but that's a ratio thing. It's not the end of the world, because I'm not sure if I can get 8mm 8mm poly. Well, probably with this amount of teeth, probably it's 16. Fuck. Oh, it's 20 teeth. Okay, let's see. Can we get a pulley? But it's just a ratio, it's just a firmware configuration. If I can't, it doesn't really affect anything mechanically. Sorry, actually we can go. Let's go to start. So 20 teeth, GT2, 8mm. Let's see. GT2 pulley, 20 teeth. Let's see. Doesn't really matter. I'm not looking for quality here. I just want to check if I can. So it's, is it 6mm? Yes, I can get it with 8, so that's fine. I would probably use a 10mm belt in here. What do they use? Oops, sorry. I'm pretty sure this is 6mm. I would... Yeah, this is 6. Okay, I would use a 9mm pulley in here instead. This is not a 3D printer. But that way I'll need to order a new pulley. Let me check what the hardware kit comes with. Well, shit. I hope it's here. Actually, it is. Spindle hardware. Well, I hope it comes on the hardware box. Yeah. Yeah. Top camera, sorry, it's a mess in here, but I was fixing this television for a friend. Yeah, these guys call for so I'm gonna order beefier stuff in his 9mm belt instead, and I'm gonna order a set of pulleys. It's not the end of the world. Anyway. So I'm gonna order a belt and 2 pulleys, 10mm ones or a 9mm belt. It makes no sense to use So it's funny, they make a 2-for-1 ratio to double the torque, and they use a 6mm belt. It's this kind of decisions that I really don't agree on this machine. Or Skyla? Sorry, I'm lost. You lost me now. So I meant this assembly here. So this is the Z assembly. Yeah, so this is the Z assembly. It goes for a Z, for a belt connection. I guess it's to make the machine not as high, instead of mounting the motor on top of the thingy, but it's fine, that's fine. I'm not concerned with that. It's absolutely fine. I would prefer a direct mount. I always prefer a direct mount, but doesn't matter. It's fine as long as the belt is well stretched whatsoever. It's fine. My main concern is they decided to use a 6mm belt instead of 9mm. So I'm not sure why, but it's not a wise decision. So even especially because they made it a 2-for-1 ratio on the pulley, so it's a 20 teeth on the motor and 40 teeth on the lead screw. So you're doubling the torque on the lead screw. Yeah, and you want bigger pulley belt, sorry, in my opinion, to manage the bigger torque. So yeah, I don't agree with that. And we are talking about cents, maybe, not even $1 or $2 difference between using a 9mm belt and the 9mm pulleys, but whatever. And since I need to order a new pulley for the motor, since the motors I'm going to be using are bigger, so yeah, I'm gonna go with that. Okay, and we don't need another, actually an extra, so we only need 2 couplers, which is cool. Anyway, so I'm gonna nothing. I'm gonna do some rough measurements in here so I can decide. So we have 80mm, which makes sense. What's this? Oh, it's probably for a zip tie. $124.21. Okay, 124. Who fucks? Who cares a fuck? Okay, so I need. Okay, let me select this guy. I'm gonna select the column because I need to. Make a hole here, just a reference hole, as I did in the all the other places. 4.2, 10 millimeters. 10 millimeters from... Why? I have 2 points. Why does Fusion do this? And 10 millimeters from here as well. And I'm going to drill everything down there. Okay, this is just a reference point, as I did in the other axis. It's just for a reference, the plate. So let's create a Z motor plate. So it's going to be 120 by 80, roughly. 121, right? What was it? I don't remember. 124, sorry. 124. 124. Okay, I'm gonna put the screws already in here. 5.2. 5.2. Okay, let's call it, should be D3. Yes, D3. So D3 and D3 and D3. Okay, so this one, it's horizontal with this one with this one. These three are vertical with all of them. I'm gonna create a point in here, and this one is gonna be like that. So I'm gonna, these are gonna be 10 millimeters from here. This one's gonna be 10 millimeters from there. This one, it's gonna be 10 millimeters from there. And actually, yeah, it doesn't matter. And these two, it's gonna be vertical with each other, and they're gonna be 20 millimeters apart. Okay. Everything looks good. Oh, no, it doesn't. It doesn't. Because this thing, it's inverted. And it's not from here, actually. Okay, let me delete these two. So these two are actually from this side. Come on. Why are you being a dick? So these two are actually 20 from that. Yes. Why aren't you moving like normal? Yeah, Fusion. Always. Doesn't matter. Let's put it for now. For now, 15 millimeters. I'm pretty sure it's gonna be, well, I may need to do we may need to do some changes here, as usual. Let me check the okay, so they have, I believe, these are 10 millimeters. Okay, I thought it was 12. Okay, so actually it's 20 millimeters here. Okay. Maybe we can work with that. We'll see. Okay, then we're gonna need a big ass slot. Big ass slot in there. So let me make a slot. I like to do center to center. It's not going to be needed to be too big like that. Maybe 5 millimeters is enough. Not sure. Okay, let me disappear with these screws and these nuts and whatsoever. Actually, I'm gonna disappear with the whole motor. Let me check my motor. Okay, I disappeared with my motor. Give me a second. I just want to check the flange thingy. Okay, 38. Let me search for NEMA. 23 dimensions. Yeah, that's it. Okay, I see a bunch of errors. It's enough to worry me. Okay, so let me, before I forget, let me correct this. So I need to open the X mount and the Y mount first. And I need to correct this. Because it's not 47. It's 47.1. It's not the end of the world, but like I said, it's enough to trigger my OCD. Hey Antonio! Same story here. Edit sketch. Whoa. Okay, so probably I projected it, right? Because I'm pretty sure I remember. Yes. Okay, so sketches. Let me see sketch. Okay, I projected these points, I remember now. Edit sketch. Yes, I remember now. Okay, so 47.1. I'm pretty sure. Yeah, that's it. And if I do from this side to this side, yeah, we are good. Okay, fine. We are corrected. So let me create 2 center rectangles on this thingy. What's the best way? No. The best way to do it is another way. I need a point first on a middle point. Actually, I need another middle point. And let's align these middle points. And now I'm going to create a rectangle center here for 47.1 and 47.1. I'm going to make it a construction rectangle. And I'm going to make 4 center point slots. and I'm gonna give it 2.5 for now, because I'm gonna need to do some stuff. So here it's gonna be 5.2, right? No, 5.2, yes, but divided by 2, so 2.6. And oh, okay. And this dimension here is going to be the same as this one. So we have D14. So I'm going to repeat. Okay, I can't yet. So another slot, center point, doesn't matter. Here it's D14. And here it's D18. Okay, D14 and D18. Oops. This radius here, according to NEMA 23 dimensions drawing that I'm seeing somewhere on Google, it's gonna be 38.1, so we're gonna call it 38. Where's my mouse? Need my mouse on Fusion. Here. 38.5. Oh, divided by 2, because this is radius. We don't want radius. There we go. Something like that. Then the center, we're gonna need to... That's for another time. We're gonna call it from the back, or maybe from the front, or from the center. Not, it doesn't really matter now. Let's call it here. Shit, I don't remember. $35. I'm not. No, it's not 35. It's less. Okay, let me open. Yes, my motor again. 34.5, almost that. So 34.5, you're gonna need it there. What have I done? There. Yeah, we're gonna need this part a little bigger. We'll see how much bigger. Can it be bigger? Can't be much bigger. Well, we'll see. Let's not worry yet. We have time to worry. So what I know something. I know some stuff. Let me make a line here. Just I know I'm gonna make another line. I know here from here I have 10 millimeters. Sheesh. X. Okay, we might have a problem here. We might have a problem. We'll see. We'll see. We have time to see. What do we need more? Okay, we need more slots in here. Slot, center slot. So D14, right? No, it's not D14. Is it? It's D17. Okay. Times 2. Okay. D17 times 2. And this one is D14. That's it. And same story here. Plot center. D17 times 2, fuck. And nope. D14, right? Yeah. Okay. This thing it's gonna be down here, and we'll see about this in a minute. So let's put this thingy for now 30 millimeters away, and for now this thing 24, nope, 22. Doesn't matter for now. Okay, let's do this thingy 20, no, needs to be more. 27, right? Needs to be the same as the needs to be the same as this one. Yeah, 27. Probably that one as well. Yeah. Okay. Well, this one doesn't need to be 27. This one can be. This one can be. Fuck, where is it? $17, actually. And it's more than enough. $17, yeah. Yeah, 17 should be more than enough. Oh, there's something I forgot. We need some screws. We need a rectangle, center rectangle. I believe it's 32 or 35. Probably 35. Not sure. X, let me check. For these guys. No, actually it's 42. Actually it's 42. Nice. And 3.3 holes. Well, this thing can be as long as we want, now that I'm thinking about it. Well, kinda. We'll see in a minute. Okay, 3.3. Let me reference these guys all the same by that one. Come on. D what? D35. 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 Okay, fine by now. Let's see how this thing lands on the... or we're gonna call this thing the motor mount. So on the column, I should have done... Okay, let me do... Okay, let me create the z-axis, new component. Z-axis. Well, z-axis, not axis 2. We're gonna move the spindle mounts, not the parametric. The parametric are actually part of the column. The cars and the Z-plate, all inside the Z-axis. These guys belong to the column. Right? So now we are working actually on a column. The column needs, okay, let me, what needs to be updated? Oh, it's the, yeah, okay, I see. What was I doing? Okay, so we need to put in the now our Z mount, Z motor mount. Okay, so we're gonna orient it like this. And where do I have a hole? It's there, so let me... Okay, that's absolutely fine, as long as the spindle doesn't hit the plate, we are good. So yeah, for now, everything looks fine. Now what I need to do is to, oops, I see, fuck off. We don't need Q anymore, I believe. I need the holes for the BK. Why? Oh, okay, I fucked up on that one. Okay, I press X on this one. There's no X. Why? Okay, fine. Jesus. Okay, we're good. We need to update. Okay, let's start loading stuff in here. So I need to load an FK10. So the other way around. It's fine. Okay, I was locking. I was thinking in other stuff. So J, rigid, right? Yes. Oh, I moved the thingy instead of blocking it. Okay, fine. Okay, I aligned instead of the joining. That's fine. We join it now. And we join the flange now. Okay, what's going on in here? Wait a minute. What's wrong? Okay, I fucked up somewhere. Let me try and understand what I did wrong. So, this thingy, it's a radius of 17, and this one should be 17 and 25. Okay. Yeah, I fucked up on the... Oh, I see. Oh, shit. I'm stupid. So I made this thingy on a square rectangle instead of a circle. Yeah, okay. It's a 42 millimeter, but it's a circle, not a rectangle. Makes a lot of difference. So X, and this thing is coincident, and this thing is coincident. This thing is coincident, and this thing is coincident. Now there's no 42 between these two. Not even 42 between these two. Where's the other one? Let me delete these 42s first. Okay, so this one, it's parallel, not parallel, horizontal and vertical. Okay, this one, it's overextended, over-constrained. Now I need my horizontal line in here. X for construction. Another one in here. Same story, X for construction. And this one to this one, I want 45. And done. There we go. And now it should align just fine. Yep, that's it. That's my boy. Okay, so now we need to make definitely we need to make a plate. Okay, let's start tuning in now. So here can be something like 25. Here needs to be something like 37, right? Yep. So this point in here, actually it's simulating the frame. So, and we want, oh, actually, no, we want this point away from this guy. So this guy, it's, okay, we can go 3 millimeters. So we can go here to 34. So this guy, it's still, yeah, can go 33. This guy is still away from that. And yeah, for now. Okay, music went away from us. Let's see on Milo, because we need to keep the same distances for the belt adjustment. Oh, actually, this seems a little on the tight side, but let's trust. We need to trust on some stuff they made, right? So let me check. I want to check the center from here to here. Global, and we have what the hell? We have nothing. So let's do 66. So we are looking into the Z delta. 66, 67. But that's for, okay, that's for, okay, I'm gonna do 67. No. I'm gonna do 65 to the, to here. So I'm gonna call this from this 65. Huh? So I can move this. What the fuck are you telling me? That from here to here needs to be driven. You have there. I have nothing blocking this. Am I blind? Okay. Okay, so I'm gonna call this guy. $65 plus this divided by 2. And I'm gonna put here 130 because I think we're gonna need this thing bigger. And okay, so now let's import a motor in here. So let's rotate it as we need to. Nice. And I'm gonna, so I'm gonna center this piece. Oh, sorry. I'm gonna join this piece with this J. Yeah, I thought about this as well, but okay, no, it's gonna complain, but that's fine. So let me check if so the holes are aligned. So what I want to check now is just the center to center dimensions. I want it to be, okay, that's, okay, I fucked up somewhere. So center to center is 61. And I want it to be 65. Right? Yeah, 65. Because if the fully stretched belt is 65.8, I want to be able to insert the belt and actually stretch the motor. Let me check, where did I fuck up? How can it be? What am I doing wrong? So here is the center. And I'm putting the center here at 67. So from here to here it's 2.5. That's 67.5. Okay, definitely something is not right. Let me check again. Probably the design isn't updated. Let me check. Yeah, the design isn't updated. Okay, okay. Okay, I forgot to update. So let's check now. So from here to here and here, okay, we have 65. And yeah, that should be fine. Yeah, let me check. Since I have the, well, I took it away. Well, I can check. We can check. We can check. What size is the belt, right? So the belt is 42 damn 200 millimeters. Okay. Okay, if we go to the amazing stuff called the internet, we can search for GT2 center to center pulley. And that's what we want. Timing pulley, so it's metric, it's GT2. And we have 40 teeth and 20 teeth. And the belt length is 200. So we have a distance between centers of 69.7. Okay, something is not right then. Okay, so if it's 69.7, I'm going to increase it to so 69.7. So that means we're going to put 66 at minimum. And we have a 5 millimeter stretch. We can go to 71, so it should be more than fine. So 66. And we're gonna have more than enough travel to stretch the belt. Now we're gonna need to do some stuff. Okay, we don't need as much here as I thought, so I'm gonna shrink this thing again to 127 maybe? Yeah, 126. Yeah, that's fine. Fine. And now we gonna I'm gonna look at the NEMA dimensions again. NEMA 23 dimensions, images, view. So we have about 57, 58 millimeters in the motor. Width, they are squared, so we need to open a case here. So what I'm gonna do, I'm gonna create a point, create a center point, create another center point. Actually, I should work on the getting sleepy. So I'm gonna measure from here to here. 6 millimeters should be, actually no, what I'm gonna do, it's other. I'm gonna measure from here to here. Ooh, 10. Okay. So here we're gonna call it 50. So we have 56.4, 57.5 should be fine. Or 58 even, 58, why not? And we're gonna, yeah, that's fine. We're gonna extrude this thingy like that maybe. We can do some 3 millimeter stuff in here. Yeah, let's call it like right there. Should be fine. And how much do we have here? 6 millimeter. Yeah, looks fine. This thing will never bend. Never. How much do we have in here? We can do the same or about the same. We have 7. But we have, what's the thickness of this thingy? 19. Oh. We don't need as much. Not even close. But we have 17, right? So that's fine. Well, we'll see. Yeah, it should be enough. We may need these thicker and deepen the BK block and move the motor up. I'm not sure, let me check the length of my motor. The shaft, I mean. Shit, they don't have the... Yeah, they don't give me the length of the shaft. Yeah, when I receive the motor I'll see, but should be... we'll see. Okay, so... I'm gonna update. I'm gonna lose the reference here. Okay. I choose the wrong side, but I can edit profile. Nope. Edit sketch plane to this side. Then I'll go positive. And yeah, everything is fine now. Ooh, nice. 2.4 is a very fun build. Okay, now I'm gonna get a complaint that it lost the reference. What you gonna do on your V0? Pretty sure you won't do okay, this is a problem. This is a big problem. Let me check. Okay, so I have 11 mils here. I need to check for this to be accurate for this part. I need to triple belted Z on a V0. Oh, that's crazy. I'm getting tired, but I really want to finish at least the ball screwing here. So let's move it. I'm not too worried about this part. This part has to be this shape. There's nothing much. Well, actually there is. I can move this thing way back. Well, it doesn't really matter. I'm pretty sure I can't cross it. Yes, I can't. Yeah, okay. Yeah, it needs to be like that. Okay, let's move in the... Oh, that's cool. That's cool stuff. Okay, let's add let me create a ball screw for Z. Copy. Yeah, it should be fine. Copy. Yep. Actually, I need to rename these to 600. Rename these to... or 560 probably, but 600. I need to rename these to Z, and it's going to be way smaller than that. We're going to see how much. So from here to here, we're gonna aim for maybe a 300Z. So rename 300. If we are lucky. Maybe we are. We can make a 300Z. So let me open it. Let's make it way smaller. So this should be fine, this part here. Now this part. So how long do we have this? So that's a 45 total. And we don't need nearly. We need like the 2.1 only, not even that. So from here to here we should have like 10, 45, 55. So from here to here we're gonna call it 295. And if we are no, we want less. We want less. We want 245. That's what we want. Try to make it 300. Yeah. So on this one, we wouldn't even need, to be honest, we wouldn't even need a bottom block, but it's a nice stuff. It's a nice touch to have, so let's try to keep it. But it wouldn't be absolutely necessary. So we're gonna add it to the column because yes, the ball screw, the ball nuts are going to the z-axis, but the ball screw, it's going to the column. Fine. So you need to join that guy there. Edge. No, not that edge. Where the fuck? Not vertex. Not face. Okay, let's disappear with the x-axis. Let's make it easier. So you gonna go here. J for joint. Yeah, that's it. So now we need to fix this. We need to match, or at least get close to match this. So most likely I'm gonna need to raise the this piece. Or raise this side, actually. We'll see. But that needs to be done. But that's this part problem. That's not a. Probably I'm gonna need to raise the part, but I need to know first the length of the motor. So I'm gonna wait. The motors will come soon. It's fine. I can mess with this part later. There's no issue. Because we have a lot here to compensate. 15 millimeters. So pretty much, but this shaft is pretty small right now. I'm pretty sure the motor is way longer than that, probably 10 millimeters. So probably I need to increase the size of this part like 4 or 5 millimeters, the thickness, and open a pocket here and increase the pocket of the motor up, and we should be fine. Assuming that the motor has at least a 25 millimeter shaft that it should have. Like, I can grab one of my NEMA 23s that I have somewhere in here and check the shaft size. Well, actually, these ones have quite a small shaft. Yeah, these ones actually have a small shaft. So this thing have a 20 millimeter shaft, actually. But this is 6 millimeters. 6.3 actually, so it's a quarter. These are a quarter inch shafts. Well, it's actually the same as this design. But yeah, that's a no problem. That's not a ball screw issue. That's not anything. The BK block can't go for lower than this because it will hit the cars, the carriages, whatever. So it needs to be that length. It can be thicker, it doesn't matter. I can always get to that part later, to this piece later. I'll do according to when the motors. Actually, we can do according to the original motors, which I don't remember, but we can check. So these guys have a 20 millimeter. Okay, we can based on the 20 millimeter shaft. We can base on that, and even here we have the stripping of 3 millimeters, but here it's lower, but yeah, okay, I need to actually put in the pulleys there to get that sorted out. Yes, that's exactly what I need. I need to model the pulleys. How long is the shit? So this is 16. So we may need a bigger ball screw after all. Let me increase these to how much is this? Yeah, I'm gonna increase this one to 15 because we want the full or close to full. If it's 12, it's fine. No, 15. That's gonna make it 15. It probably should be even more. And this guy for now to 40. So we have a 300 still. Yes, we have still a 300. We'll see where we'll get from that. Okay, let's import the. Oh, we have it already, right? Yes, we have it already. Let me see where it gets down there. Okay, okay, that's doable. That's doable. That's doable still. Okay, I'm gonna create the lower part now. There's no. Yeah, there's no point of copying the top one because this one it's way smaller. Well, it's always easier. So let me do that. Let's copy this one, copy. To. Oh wait, this is not updated yet. That's 5 millimeters shorter. It's going away. It's going away. The dream, it's going away. We'll see. We'll see. We may need a longer ball screw. We'll see. So, I copied the Singy. Let me rename the Singy to Z FF10 mount, and let's open it. There's a bunch of stuff we don't need, like the motor and stuff. So we're gonna start with this. We're gonna in these and these, and for now, let's delete all of these. Yep. And let's make it way smaller, like 60 smaller. And we need to fix a bunch of stuff here. Like this one, it's 14. Is it actually? Let me check something. FF10 dimensions. Yeah, that's good. Okay, so fuck, can't read that. Why not? Okay, so FF10 DP DG6. Okay, I need to fix some stuff. Where is the other FF10? It's the Z FF10 mount. Okay, I need to fix this to be bigger. So it's 28.5. So it's 28 the default measurement, or the official dimension, but I wanted a little place, so I'm gonna make it a a little bigger, 28.5, just to make sure everything fits. It doesn't need to be a tight fit at all, unless everything is perfect, but stuff hardly is everything perfect. So the 4x, it's PCD, we have 35, so here it's 35, and here it's 2.5. I'm gonna need, okay, let me open the, no, fuck, this is the one opened. Need to, oh, it's there, yeah, it's there. Let me check this dimension here, from here to here. This is actually what's important. I'm gonna actually delete this one, and I'm gonna make this driving. 28. This is the most important one. Finish 28. That's it. 28. Why? Oh, because I have this one. Okay. Toggle driving. Okay, so I probably, no, that's fine. That should be fine. Okay, this one can be we can do it 12 millimeter, and we can do center rectangle here. I need to check what I have done on the others. Fuck, I closed it already. Yeah, that one can be. So from here to here, 37 and 7. So the 37 minus age 7 can even be more actually. Let's put minus 10. 10 it's too much. Let's put 8 for now. 8 minus 8. And we have some F7 here. These corners. And let's see where this takes us. For now. We can do some later. So we need this guy. How is it? Of course it's the other way around. So it's like this and like this. And which one is the, it's that one. So we need to assemble this guy with this guy, J for joint. Boom. And now we need to where is the, we need the FF guy. So 270, like that, should be fine. And we need to match these holes, J for join. Boom. Okay. Now, nah, there's no way. We need to... Yeah, we need more. We need more. We need more. Not much, but we need more. So we need 10 millimeters more, actually. Okay, so should be 310. Fuck me. Rename. And we need to increase the to 250. Now again, this, and it's not absolutely necessary, but yeah. Okay, I have some stuff in here that it doesn't like, but oh, it's because I fucked up on the in here. I saved the sketch and it disappeared with a part, and Fusion doesn't like when parts disappear. Yeah, everything is fine now. Yeah, okay, I could make this part work, like, well, no, there's no point. There's no point of even trying. Okay, there's something wrong in here. FF, nope, Z. Let me close that one. Okay, that's something wrong in here. Which is what? Everything is defined. Okay, it's here. I see the problem here. Let's delete that and let's put this one at 10 millimeters. And now we should be fine. Let me finish sketch. Save. Boom. Now we can do some beautiful stuff in here like this and this, and then do this in here, something, a big chamfer in here, even bigger, 12 would be cool, can be even more. And do some bores in here, 9.5. Let me find out that guy, D58. Okay, D58. Fuck. Yeah. -5, 5. So everything is hidden. 5.5 maybe. And Then some chamfers, make everything beautiful. Like 0.8 and add another one. Here of something like 1.5 to be a little bigger. Something like this. And I'm gonna close it because it doesn't really matter for now. And let's update the design. And yeah, everything kind of cool. These chamfers can be even a little bigger, but there's no point. Okay, so yeah, I'm tired. I think I'm gonna finish here. Even that I would like, I just want to try a couple more stuff. Okay, so on the Z-axis, let me add 2 nuts here. Wait, I need to select it first. So I can add 2 nuts in here. Let me put them somewhere we can actually. Oh, I'm gonna add another one. Let's move them so I can see them. Why? Move. It's because it's hidden. Come on, Fusion. Okay, so one like this. One like this. No. I don't want to rotate it. I want to move it up. Okay. Let's disappear with some stuff. Okay, we lost music again. Okay, let's disappear with the spindle mounts, with the spindle itself, and actually with the plate itself. Okay, how long? So this should be a very close, so about 40. Let me check. Jesus. So no, I can disable this thing. I can disable the table. Disable the saddle plate. So what I really want to check is how much is from there to there. Nope. Where are you? Okay, from you to you. Okay, so we can use the same, that's good. We can use the same ball mount, since we have even less space in here than we have in here. We have 2 millimeters less, which is bueno. Let me activate this stuff. Where's the table? Forgot the table. X-axis, table. Okay, so that's bueno. So I'm pretty sure we can actually, I need to check. If it's not the same, it's very close to the same. So I'm gonna make a copy of it. Yeah, it's this one. Copy. And copy. I'm gonna call it Z, evidently. Okay, let me open it. Come on, open. So let me check. So we have 20 millimeters. Let me activate the Z plate. Jesus. Okay, Z plate from here to here. Yeah. Of course, we have a stupid. Let me check. Maybe I'm selecting one on top. Yeah. Okay. Okay. So yeah, pretty sure. Probably we can't, because I think the other one wasn't centered, right? Was it? I think it was out of center, right? Here to here, here. So we have 920. Yeah. So probably we can't use it because of this, unless the Z plate, it's also out of center, which it kind of looks. Let me check. I'm gonna capture. Pretty sure I'm not gonna need. Shit, I'm too lazy right now. So I'm gonna create two. I'm gonna project these two lines, and I'm gonna just no. I think this one is fine. No, actually it's not. It's fine. It's not off center. So basically we can't use it because exactly of that, it's not off center. So I need to fix that in here. I'm gonna put it like that. Boa noite, Diogo. Como é que estás, my friend? Okay, so now it's centered. Let's try to use it. Let's see how it lands. I'm gonna finish the sketch. I don't even want the sketch active. Okay, so let's see. Thank you, my friend. Okay, so let's see if we can use it as it is. Okay, there's an update on the... So we need the Z double nut mount. Yeah, probably we can't use it exactly as it is, but I fucked up somewhere. Okay, so let me see how these should be mounted. Okay, so we have offset in here. These offsets should be on the lower side, probably. Maybe we need to offset even more the holes, but for now, let's see how far off we are. Let me join with that thingy. Fuck. Yeah, we shouldn't be too far. We shouldn't be too far off. Okay, let me check about the center of the hole, if we need to move anything around. So let's select that center and the center here. And let's see. Ooh. Okay, we are off. Okay, we have some stuff off. Okay, we need to move. Closer to the plate. Can we? Okay, we need to move 2 millimeters closer to the plate. That's first. We have a difference of 3 cents on X, which I'm not even gonna try to find out what's the problem, because that's very alignable. And yeah, that's pretty much it. So okay, let me do a couple of things first. Let me disappear with a column. Oh, okay, we have a problem here. We have a big fucking problem here. Because these guys are stupid as rocks. Okay, let me attach the ball nuts. We may need to modify the Z plate as well. Come on. Which one is that one? It's that one, right? It's fine. Okay, we need to move this thing minus 0.1. And yes, we need to add the 2 disc springs as well. Like that. And we add a nut on top. Okay. Okay, so a few things we need to change. First thing, we need to move this thing 2 millimeters down, or we need to move this thing 2 millimeters the other way, which I think I prefer to do that. So what I'm gonna do is to move, so I'm gonna add here 2 millimeters, and I'm gonna add here 2 millimeters as well. Fuck. What went wrong? The hell? Oh, okay. Okay. It's because, okay, I see. It's because this thing created, when I changed the okay, if you, so Diogo was asking what I think about the door on Volta, but in Portuguese. Well, I would prefer a V0. It's cheaper. It has more build volume. But if you really like the Delta, it's a nice printer. I have one. I love it, but it's not very efficient in the space it takes. So, but yeah, I really like it because it's a Delta. I really like the Delta kinematics. Now, if you want to build a Delta, that's a great printer to build. But if you need a printer, a small printer, and it doesn't need to be, and you don't really want it to be a Delta, I would prefer the V0 because you have a bigger print volume, and it's even a smaller printer. I have both in here. I can show you a size-by-size comparison. And the V0, it's much smaller, and it has a bigger build volume, but it's not a Delta. The Delta kinematics, it's totally different. I really like it as well. But, yeah. Percebeste ou queres que eu diga em português? Okay, and I need to change also the ZF 10. So here it's 30, and most likely I may need, yeah, well, I don't need to, but I will. Let's set 2 millimeters to the front. Okay, let me check now. Everything should be aligned now. Again. Okay, so first, oops. The fuck have I done? Wrong, of course. Oh, oh. Okay, let me disappear with the Y, with the saddle, actually with the base as well. Okay. If you need beds, I have some machined. But if you have a CNC, why not? Okay, what the fuck have I done wrong? Well, I think I... Okay, I'm gonna start with this one. I'm gonna take it back to 60. And 28 in here, right? everything should be fine. Z motor, same story. I did so 126 and 30. Oh, I see. I see what I did wrong. I did this wrong. So this is 33. This is 128. And this is 30. Probably. Yeah, okay. I forgot that one. Okay. That's what I did wrong. Okay, let's do this again then. So it's 30 in here. And 62 in here. And should be fine. Yeah, I have some machined actually. I think I have 2 of them machined. I think I have 2 or 3 for the Velta. I think it's 2. Ring me on Discord or on my Facebook page, whatever. Yeah, but I think it's the other way, so it doesn't... Yeah, it doesn't really help. And I can't move the other way, so okay. So let me undo whatever I did. Yeah, I really need to sleep. I would really like to finish this today, but... So 33 in here. And 126 in here. Then in here, it's 28. And 60. It should be fine. And in here, it's the same distance. It's 20, right? Okay. Do I have 20 in here? Yeah, I do. Close. Okay. What do I need? Okay, I need to move this guy. Probably. Nope. Probably. Nope. Probably here. So 17. Thank you for joining. It's always good to have new people. Okay, I really don't like... Well, we'll see. We'll see where this gets. I'm probably gonna start... I'm really tired and it's not helping. I have the ball screw dimensions anyway, so I can talk with the suppliers. Oops. Yeah, okay, I forgot to save. Let's see. Let's see now if everything is aligned as it should. Okay, on z-axis, actually no, on column. I'm gonna disable this guy and this guy. I can see actually. Okay. Looks good. Oh yes, I'm doing these changes to actually build a Milo. Let me disable this guy. Right now I'm checking whatever yeah, okay. That's the problem. I'm checking whatever modifications I want to make, so I can buy everything I need and then start building the machine. Okay, so the problem here, this is a big problem. I'm not sure if I can solve this easily, at least. The problem with this is the guy that designed this wasn't friendly at all. How much do I need to... Okay, so you see the cars in here are hitting the second nut quite badly. I need to offset this so much because the guy should have... Why did he place the screw holes in here and not in the middle of the plate with so much space? That's a question. If you guys see him, ask him, hey dude, why the fuck didn't you place the screws in the middle of the plate? First, the guy is completely allergic to do symmetric stuff and stuff aligned in the middle. That's the first one. Okay, so let me check. How much do I need to offset the... Jesus, that's too much. 4.6 millimeters. No. Mach 3, I already have my router. I'm not going to. RepRap, I might try. I'm not sure if I am even trying. What I'm really thinking of, it's Linux CNC. I would like to try the RepRap, the original firmware, just to see how it is. But the idea is to go to Linux CNC. It's much more capable, much more reliable, much more customable. Yep. Probably with a mesa board, with a a 7i96, I believe. It's what I was looking at. It's expensive, but it's one thing. Though I heard that the yep, exactly that one. I heard that the new That's nice. Where did you bought it, if I may ask? But I heard that the new board from BTT, the Scylla, whatever they call it. Yeah, that's what that was where I was looking at. I heard that the new one you can actually make it work with Linux CNC, but I'm not sure yet, and it's a lot cheaper. But it's not a Mesa. I'm looking into the Mesa ones. I'm really interested in that one. Okay, so what was I doing? Okay, I need to try. Yes, that's what I want to. I want to put a Raspberry Pi, big ass touchscreen, Pi 5 maybe, Linux CNC, a 7i96S with connected with an Ethernet cable, and yeah, that's the idea. That's the idea. I don't need these. No, I'm going with closed loop steppers. They call it hybrid servos, but they are actually steppers with encoders. So yep, exactly. It's plenty for this machine. This is a small machine, so my router has servos, my big ass VMC has servos. This one I'm going with easy servos. They call it they call it hybrid servos, but they are not servos. They are just steppers with feedback. Oh, it's here. Okay, so from here to here, yeah, I don't have enough space. So Z-plate needs to be modified. Now, let me check something. Well, yeah, I still have it. 4030, a CNC of 4030, and it ran with steppers, 0 issues. For a long time. 0 issues. Okay, so yeah, that should be fine. No, actually that shouldn't be fine. Yeah, I think I'm gonna stop for now. I think I'm gonna stop. Well, it should be fine. Worst case scenario, we need to edit the spindle bracket or the thing with steppers, I don't trust steppers. Especially on a CNC, because if that thing loses a step, on a 3D printer, that's fine. Worst case scenario, the filament just goes a bit out of place, barely noticeable. But on a CNC machine, that's a whole new thing, especially milling metals. So yeah, I got a good deal on those encoder, on those closed loop steppers, and yeah, I haven't even thought twice. So for the price they cost, should be fine. Yeah, but anyway, I'm gonna stop. I'm really tired, and the more I look to this design, the decisions the designer made really aren't the best. So I'm gonna stop. I'm gonna close everything. Gonna save. I don't need to save this. Unsave. I have what I wanted. The designs of the drawings of the. Okay, these I will save. The designs of the ball screws. So that's what I wanted. That was the main goal for today. Finish the drawing of the ball screws so I can talk with sellers. And yeah, it was a really nice deal. And that's it. So tomorrow probably won't have. I was thinking about doing a stream after lunch, but tomorrow it's Christmas Eve. So no. So on Christmas Day probably also no, because it's family stuff. I need to go and visit everyone, and presents and kids and drinking and eating. So see you guys on Wednesday. I really, for those of you who celebrate Christmas, have a nice Christmas. Eat as much as you can, drink as much as you can. Have some nice quality time with your family. That's all it is about. Have fun and lots of presents and whatsoever. I wish you all the best. Thank you for keeping up with my stuff. You guys are awesome. You guys make me company. You guys make me go forward with this stuff. And yeah. Good evening. Good night, everyone. Take care. Wish you the best. See you guys on Thursday. Oh, Nadir. Well, I was just about to go. Yeah, it started to be cold in Portugal. Yeah. It's like something outside should be something like, I don't know, 3 degrees Celsius, something like that. So yeah, it's starting to get cold. We don't get much cold, really, like really cold, but we are used to it. So It's for me cold. I like cold better than the heat because the heat it's extreme. But yeah, I really get cold. So again, eu sou da zona de Santarém. So I'm from the center area of Portugal, like the geographic center, not the what they call it the center. But yeah, again guys, take care, Merry Christmas, have fun, drink, eat, have quality time with your families, and we see you around. See you guys on Thursday.